there will be more. So thanks for letting me come in and join y'all and talk about one of my favorite tools, SSH. I call it the original VPN. That's what I use it as. With tunnels, I can connect all kinds of services and do tunnels and things like that. It is my preferred mechanism for reaching out and touching remote boxes. And it's also, of course, highly invaluable as a sysadmin tool and infrastructure and so forth. And yeah, so thanks for letting me in. And I did some extra research for this particular presentation. I've been giving this presentation for quite a while, but last week I did some extra research and went out and visited Puffy at the aquarium. So, all right. I do have some presumed knowledge for this presentation. I presume that you understand basic SSH usage. I'm going to cover it real quickly, but you need to know how to set up your keys and things like that, the file system permissions and so forth. Same thing for fingerprint usage. So some introduction. So what is SSH? Secure shell. That's there. It's where the S is from secure and sh from shell. It is a replacement for the RSH tools. For those of us that are around long enough to remember what those are, those were not secure. They were not encrypted, SSHs. OpenSSH is a free software fork of the original SSH project, and it's an OpenBSD project. So I always want to say thank you to both the OpenBSD team and the OpenSSH team for maintaining this tool for us and giving us updates over the years. As I said, it's essential for sysadmin, DevOps, and I've got a couple pieces here that are kind of important to what it is that it creates a secure, authenticated, encrypted connections between computers. HTTP or HTTPS anyway, can be used to create unauthenticated connections and authenticated connections. SSH is only doing authenticated. It allows passing data across encrypted TCP connections. It does require an account on the remote computer, and it creates secure, authenticated, encrypted connections across hostile networks. And this is also something new I've added. It's a really important part of what SSH is doing. Because yes, I did say hostile networks. There's a secret with that. They're all hostile, right? The internet, if you're connecting across somebody else's network, it's a hostile network. You don't know what's going on out there. If SSH isn't secure, connecting from one endpoint to another endpoint across the internet, then it's not secure. The other people run those, other companies run those routers that you're depending on to get from point A to point B, and you, from your perspective, cannot consider them to be friendlies. You can't consider them to be not trying to take advantage of you, to spy on your connections. So you need to be able to depend on that SSH connection being secure across the internet. All right, so basic connection. Oops, sorry. This isn't mapping out. We'll get it there. All right, basic connection, SSH, and then -P22. That you don't normally need to say that. 22 is the default port. So here I'm just saying please use the default port, and then give it a remote name to get to. And the key for this is it needs to be a remote name that your current machine knows how to get to. If that remote machine is behind a firewall or doesn't have a DNS entry, you need to come up with something else. If it's just DNS, you can use an IP address. But you need to have some way of getting that. But you can also have local aliases and so forth. Now here, if I talked as fast as last month's speaker, I could go through and do the full dissertation here in 3 minutes. I don't have that type of time. So there is a lot of security going on under the hood that I'm not covering in this presentation. Please go through and do that research on your own and understand how SSH just does key verification, how it does handshakes, etc., etc. I guess they should be elbow bumps in the days of COVID, right? But it's still doing that, making that connection. So let's talk about a basic tunnel. And so first, again, we're talking SSH, and then we call the remote machine. And in this case, I'm going to give a -L, then a port number that I want to talk to locally, a colon, what machine the remote machine should talk to, and then a colon and what port that remote machine should talk to. Now, this is the easiest case. I'm saying create a tunnel from port 2222 on my machine to the same machine I'm SSHing to, right? So notice that I'm SSHing to firewall.example.com, and I'm also saying create a connection to firewall.example.com, and then I'm creating that connection to the SSH port. So basically what I'm doing is creating a tunnel from 2222 on my local machine to port 22 on the firewall. So I'm making the same connection as the original connection. It's just creating a tunnel now. And then to enter that from a different shell on my local machine, I can use SSH. Again, this time we need the -p, lowercase p, and we specify 2222 because we want not the default port. But then we talk to localhost. We don't talk to firewall.example.com. We talk to localhost, and we talk to port 2222 here, and that opens a new connection to the SSH server on that remote machine. Now, since we're doing that, making a connection to that server, I'm not using the same connection to connect. I'm just using it to get there. So I have to re-authenticate. That's an important part, that I'm going through that authentication handshake again when I do that. Now I have an example. Craig has been kind enough to help me out with this. Let me adjust where I am. So I have here, where am I? There I am. Okay, there I am. I got to figure out which side I'm on. A PVC pipe, and I've created that tunnel. So what I did is made the connection. I lay the tunnel across the connection, and that comes into Craig. And then I'm going to send him a die across that SSH connection. Now, important here is you couldn't see what I sent across that connection, right? I've got 3 dice. I can send 3 dice. I can send 1 die, right? You can't tell. But what you can actually see is it's not really an enclosed connection like this. It's really more like a bunch of cargo train cars, so that you would actually see the data that's going across. So you can see how much data I'm sending, Craig. You just can't see if it's something worthwhile. And you can't see what number I rolled unless he shows you, right? So that's what SSH is doing. And the tunnel is allowing me then to send whatever data I want across that tunnel, as long as both sides agree on the protocol. So, and then I also give you an example here for SCP, where I can use that same tunnel. Here I need to use a capital P to specify the port. And then I use my normal SCP options. So I say send that across localhost, but it's really connecting to that remote machine. Secret role, yes, that is important. If we'd have been really good, we'd have had secret sushi rolls, but that's probably really messy on the network. All right. So to give a diagram of the tunnel, go through, remember what slide I'm in, and oh, there we go. The diagram is on the next slide. And actually, I'm going to kind of skip that. I'll leave it there for the slides, but let me see. Where am I at? There we go. So I'm going to actually use my Siegel speaker gift from a couple years ago. They gave us a travel kit for travel utensils kit that I have added other stuff to. And of course, since we don't get to travel anymore, it doesn't really get used. But we'll use this boba straw as my initial connection. So I come in and connect to port 22 on that remote machine, and that's my initial tunnel. Then I make another SSH connection from my remote machine across that tunnel, and that also comes in at port 22. Right? We're going to get this a little bit more complex as we go. All right. Now, how do I prove that I'm doing this? So what's the difference between the lowercase p and the uppercase p? The lowercase p is for SSH. The uppercase p is for SCP, because if they made it the same, that would make sense, right? No, the lowercase p is actually because SCP is coming from CP, and lowercase p says preserve attributes. So lowercase p was already used when they created SCP, so they moved to uppercase p for the port. Now, when I make that connection, I can use SS, which is the new version of NetStats, to go through and look at the TCP data to check what my connections are. Now, in this case, I added some extra blank lines in between just to make it a little bit more readable. And I noticed I changed it. It's a different machine. I just did demo to make it easy across here. And I used 127.0.0.1, which is the IP address for localhost. The key here is that it's the IPv4 IP for localhost. When I did this just specifying localhost, internally it used IPv6, which is awesome, but I didn't feel like explaining that during the presentation. So I went with the simpler IPv4 setup. So here I have the remote connection. Let's see. Actually, I don't even know. Can you all see my mouse? I was kind of depending on that. I don't know. Probably not.
I saw it before. I'm not seeing it now.
Okay. So, oh, wait, maybe is it up here? Can you see? Oh, there it is. Oh, awesome. And I can do things. All right. So here is the IP of localhost, which down here I've done a host name -I to show that that's the IP for demo. And then to the right of that, I have the IP that I'm coming from demo's perspective. And then it tells you what port was connected. So I'm coming from TCP port 56470. We use for outgoing TCP connections, we use large TCP ports. And then back on demo, I connected to the SSH port. Right? Now, when I create the tunnel, I can see that the connection is coming in from 127.0.0.1 on the SSH port, and it's coming out on 127.0.0.1 from localhost on port 37070. And then that same port is reconnecting. Here on the right, we see that it's 37070 is reconnecting back to the SSH port on localhost. So it is coming in demos SSH, going out demos localhost, coming in demos localhost to demos SSH. So I can show that my TCP connection that was using the tunnel is indeed using the tunnel because the connection is coming across localhost. All right. Now, we can also do this in reverse. I have not yet figured out how to do the bash stuff. I would need to get it go when it's backing up, but it can go in reverse. All right, so it's a similar type of command, but in this case, oh, I got the backup dog anyway, I guess, if you all can hear that. So in this case, I'm using -R instead of a -L. But now that port 2222 is on that remote machine, and because I'm doing reverse, I'm starting on that remote machine, and then I'm coming back to port 22 on my desktop. So I'm now going the other way around, right? So I'm leaving on a jet plane. No, I'm leaving on a large port on that remote machine, and then I'm coming in to 22 on my desktop via that tunnel. Then I can, from that remote machine, excuse me, take that back. Yeah, from that remote machine, I can connect to port 2222, and that's now connecting back to my local desktop. So where is this useful? Well, if you are sitting behind a firewall of some sort where you don't allow incoming connections, or your SSH connection is blocked, or you just don't want people to be able to see that you're connecting to your SSH port, you can then SSH to your remote machine and then SSH back. Now, note you can do that in the same session, right? I could do that from the same shell, SSH to the remote box, and then SSH back to my machine and do that. But I can also leave the tunnel up. And when I'm at that remote machine, I can now get back into my local box. And you're like, but Hans, now I've got an open connection to my local box. Isn't that a security issue? No, because you're still connecting to SSH, and you still have to be able to authenticate to SSH. So you're not leaving an open connection to your box. You're leaving an open connection to your SSH service, and then somebody still needs to be able to authenticate against that, or have an SSH exploit that they can use from your remote machine once they're on your remote machine. So please make sure you keep doing updates so that doesn't sit around. Now, in these examples, I'm using firewall.example.com in both sides. Where is localhost on that? I kind of explained that earlier, but I wanted to give it to you in a text example. So basically, when I say this should be a local tunnel example instead of remote tunnel example. So presuming that both of those capital R's were capital L's, this slide would be more correct. I'm SSHing to firewall.example.com, setting up a local tunnel from port 2222 to firewall.example.com to port 22. But I can do that via localhost because I'm telling firewall.example.com to find firewall.example.com. And one would hope that the setup on firewall.example.com would be sufficient that it can go, oh, that's me, right? If not, you've got other issues. Always blame DNS. So anyway, so I can now say localhost instead. If I were doing this as a remote tunnel, as the example I have here, that localhost, again, is interpreted by the machine setting up the tunnel endpoint. So that localhost would be my desktop, right? So firewall.example.com wouldn't be looking up localhost. My desktop would be looking up localhost. Now, we can make this even more fun. There's the traveling slides. By tunneling via third party. And with this, if both machines that you want to talk to each other are on networks that are behind firewalls, or otherwise you don't want to or can't allow incoming SSH connections, they can connect to a third-party bastion host. Now, the third-party bastion host might be the firewall server that I've been talking about, right? But it also might be a droplet out of DigitalOcean, or your aunt's, barber's, cousin's, third neighbor's, fishing buddy's system that they've got set up at a remote farm somewhere. I don't know how good that bandwidth would be, but hey, whatever, right? So we can connect up to those. I'm going to use firewall.example.com as the thing. And this is specifically has to do with when I wrote my Linux journal article, is what happens if I can't trust firewall.example.com? Well, as it turns out, I can't, because I'm not the root on that box. Other people are root on that box. And in the case of where I was working when I wrote that article, I was handling student data that the sysadmins on my bastion host were not allowed to look at, and I couldn't give them access to. So I needed to make sure that I could transition that firewall without them being able to see the data. So I needed to, even though I needed to step through the firewall to get to my internal box and to my servers, my application servers, I needed to make sure that the sysadmins, friends of mine, but I needed to make sure that the sysadmins on that firewall could not look at any of that student data that I was moving back and forth. And I actually needed to be on 3 different networks with that student data. So I had to transition this back and forth. And I used the same mechanism in a much more complex setup to transition my laptop so that the data never went on my laptop. It only went across secure connections from one network to another network because of the way that they had things set up, where I had to be able to share data between different corporations. But I didn't want my laptop at my home or at a cafe or wherever I might have it to have any of that data. So I could go through and make sure that even I did not have access, did not have the data stored or unencrypted locally at any point, right? And in this case, most of the time I didn't even have shell access to the data. I was doing jobs back and forth, so I didn't even have it in a shell for somebody to screen capture if they got on my laptop. So I can make that reverse connection, SSH into firewall.example.com, setting up the tunnel from 2222 on the firewall back to my desktop. And then I can also set up a connection. Well, did I confuse myself again? I went and updated these. Okay, there we go. Oh, this is okay. I'm a slide ahead of where I'm at. So this is just showing a simplified example of the reverse connection and the forward connection for a single box, where I'm using localhost instead of firewall example.com. This is the slide where I was just talking about for the double reverse. So on this one, I'm setting up that local connection again from port 2222 on my local machine to port 2222 on the remote machine. So I'm not talking to the SSH port anymore. And then from the remote machine, I'm talking from port 3333 back to 22 on my server. So what I've done is, where did I put the, there we go. I've gone and created a connection that is 2222 back to, let me see, this is a local. So I'm going to do this. I'll use a floppy straw. So this is the yellow straw here is the local connection from port 2222 on my local machine to port 3333 on the remote machine. And then I've in turn gone, or port 2222, I've gone from port 3333 on that remote machine to 22 on my local machine. I'm going to run out of floppy straws here. That's okay. We can make this work. And then on the remote machine, on the other machine, the further remote machine inside the firewall, I've connected from 3333 back to 3333 on the on that local machine. And additionally, I'm running out of hands. I meant to actually make something. We had this as a project with my kid. We didn't quite get there. Here we go. Back to 2222, or from 2222 to port 22 on on that remote machine. Now, what this turns into, I'm going to drop some of the extra connections. Is 2222 on my local machine, then binds to 2222 on the firewall, which is in turn bound back to 22 on that remote, on the internal box. So now when I make a connection across that port, notice that the data moves the tunnel, and it never gets unencrypted on the firewall. It's going across the tunnel the whole time. And when I make an SSH connection, I do that and I get a prompt. If I've got keys in place, I don't necessarily get a prompt. But let's say I'm just using password authentication. Then I'm connecting to the SSH server on that internal machine. So when it says, what's your username and password, I'm talking to this internal machine. I then need to make sure that my external machine knows the SSH key, host key of that internal machine in order to authenticate properly. All right. Okay, next we're going to throw the connection. So this is similar to what we just did with the local tunnel, but now instead of having the destination being a port on that local, on the firewall, I'm making the destination an internal machine. So in the case of the previous slide, if the firewall can talk directly to that host 2, I could, instead of needing to well, I actually can. That's what I did, right? I threw the connection to 22 on that host 2. But I can throw other connections as well, as long as it's TCP. So this is a MySQL example. And this is saying, okay, I'll explain what the NNF are in a couple slides. But I'm saying throw port 3306 from my local machine to port 3306 on mysql.example.com. So the internal database server, hopefully internal database server. Please don't put your databases on the external on the internet. On the MySQL server. And now when I make an SSH connect, or make a TCP connection to port 3306 on my local machine, I'm actually talking to that internal MySQL server. Now there are two pieces here to take into account. I'll get to those in a little bit. Let's see if y'all can figure out what those are before we get there. One of them is specific to MySQL. Well, actually, the one specific to MySQL I'm going to get to in a little bit. The other one I'm going to get to is to note that thrown connection going across, where's 3306 would be in here, right? That thrown connection, actually coming this way, is not secure. There's no tunnel this direction, right? All it's doing is throwing packets that direction. It's not setting up a secure connection to that remote machine. It's just sending the packets there. So if you connect from your firewall to that remote service or to that internal service with an unsecure connection, then this data is readable. Also, this networking stack on your firewall can read it. So if you don't trust your firewall, which we shouldn't, then that can also connect it. So if you want to make sure that this final leg is connected, you need to make sure you're using an encrypted connection. So MySQL over SSL, for instance, whatever your internal service is. All right. So as I say, be careful that unencrypted leg, because that last piece is not encrypted. All right, another slide. All right. We can also do SOCKS connections. And what SOCKS does is allows you to send any TCP connection across the port, and it makes it look like it's coming from your remote machine. So SSH-D 1080, that sets up a SOCKS connection on 1080 of my local machine. I connect to firewall.example.com. I have to authenticate for SSH. Once I've authenticated, it sets up that tunnel, and then anything that can talk SOCKS proxy can use that connection to appear to be coming from firewall.example.com. So this is a way of basically using SSH to create a VPN, a TCP VPN, to appear to be coming from internal host or from inside the network. For Firefox, I highly recommend Foxy Proxy. I don't need to use it so much nowadays, but back when I worked at that company where I had to be on 3 different VPNs and be doing different things, Foxy Proxy saved me. I also use different Firefox instances now, but back in the day, I just used one instance. But that allowed me to set up rules for each of those different VPNs. So I didn't have to do like everybody else at the company, which was set up a VPN, drop it, set up a different VPN, drop it, set up a different VPN, drop it. And they spent their entire day just juggling VPN connections. I set up all my SSH connections at the beginning of the day, and I was able to use them and move data back and forth. And as I said, I was using tunnels across my laptop, so I was even making sure I was encrypted locally. We can also make a graphical connection. We used to use a -H to set up an X connection. There was a security issue way back when that I mostly kind of understood at the time, and it's been a long time, so I don't remember. Just use -Y. So -Y will say set up an SSH connection. If you're talking to a headless server, you need to make sure that you've got a little bit of X installed. Basically, at least on Debian boxes, if you install Xhost, that usually gets you enough X to set up the connection. So you don't need to install all of KDE or all of GNOME or Rat Poison, I guess, whatever you need to do. That's usually sufficient. But of course, if you're connecting to a local desktop, you can do that. And now you can throw things back across. So for instance, I can throw an SSH or a Firefox connection from that local machine or from that remote machine back to my local machine. And I give you an example down below of how to do that with a container. It's the same thing, but I can use a container. So I can set up a container that is doing something. So for instance, when I first started using KeePass XC, it wasn't available as a Debian package, and I wanted to make sure that it wasn't making any network connections. So I set up a container, installed KeePass XC, and cut off all the networking except for my SSH connection, and then set up X forwarding so I could connect in, use that KeePass XC for my testing, and then see if it tried to make any network connections, and make sure that it wasn't able to do anything. All right. Then for keys, So all the examples always say make it SSH .ssh/ID underbar RCA or RSA or DSA, and give it the name type. I give it the name of the thing I want it to use for. So I use different keys. Don't use the same key for every connection. If you're a consultant and you have different customers, set up a different key for each customer so that if something happens and there's a compromise, you don't compromise all of your customers. When I was connecting to 3 different networks, I set up a different key for each network to make sure, again, that I'm keeping them isolated, right? So I would give them names that were useful. Network 1, Network 2, Network 3, so forth, right? Set up your authorized keys. I'm going to give some more examples for those. And then there's also SSH copy ID, which is useful. So when you're first setting up a new box, SSH copy ID will copy your key over for you and set it up properly. Get the permissions right. That's the thing that always kills us. You copy them over, you know what you're doing, and you don't get the permissions quite right because you forgot something. SSH copy ID will make sure that's all right. It's a shell script, if last I checked. All right. Some service examples. So back to MySQL. So the thing, for those of you playing at home, if you didn't figure out what it was, is that when you connect to MySQL and you use localhost as the host name, it tries to use a socket connection. So you have to say instead use 127.0.0.1, and then they go, oh, okay, I'll use TCP. It's a MySQL thing, and it cost me much consternation when I was first setting it up. Or you can tell it to use protocol TCP, as I have in the first example. All right. So here's an example for email. So I'm setting up 143 for IMAP, 983 for secure IMAP, 25 for SMTP. Technically, I should have more ports in there, but I didn't want the example to get too terribly long. Now I'm throwing all those back out, and I can make a secure connection even to unsecure mail ports because I'm using SSH to talk to the local host on the mail server in order to do that. Actually, in this case, there are different servers. So again, that last leg wouldn't be encrypted. But if they were all on localhost, then you would be talking secure into the mail server. All right. So for web examples, we'll use a capital L port 8080 to set that up. Common port used for web examples. In this example, though, when you connect up to it using a web browser of some sort, curl, wget, what have you, if you say connect to localhost or if you say connect to firewall, then it's going to give that as the host name you're trying to connect to. If you're using an SSL connection or TLS connection, more appropriate nowadays, if you're using a TLS connection, then it's going to say, hey, I want to talk to localhost. But that's not actually the web server you're wanting to talk to. So you need to send it an extra header and say, this is the server I want to talk to. But now if you're talking to a server that's got a whole bunch of different virtual hosts on it, you can set up one connection and talk to each of those virtual hosts. You just need to remember to set that extra header. Again, Foxy Proxy is really helpful for this. And ASCII Puffy, because why not? So Puffy, by the way, is the I think it's the BSD mascot, but it's also the mascot used for SSH. So we use that. I forgot actually to get my puffies out. Here we go. I have a very small mascot collection going. All right. Some config tips. One, use multiple known host files. So hopefully everybody knows what the known host file is, but you can use multiple on newer version or newer distributions. And newer distributions means CentOS and RHEL that was released like 8 years ago, which means just not necessarily in production yet. Please, everybody update. But most anything that's come out as a release in the last few years will have the capability of using multiple known host files. The place where I use this is I have my known host file. That's my main known host file that I use for myself, including adding new systems to. But then I have another one for orchestration. So if I'm using Puppet or what have you, I can grab the IP or the SSH keys out of that, build a centrally managed known host file. So now I have the SSH keys for everything in my infrastructure. If those change for some reason, I get the new ones. If we're doing the whole start 50 new web servers and kill off the old web servers, I get the 50 new known host files, and the old ones can go away, right? So I can manage that centrally and be able to use that to make sure that I'm getting secure connections. Now, granted, in most of those environments, we shouldn't be connecting as humans into them via SSH, but things happen. We need to be able to do stuff. All right. And then you could also set up, or here's the example, user known host files, and then you can list out multiple files. SSH authorized keys. I said I was going to get to a couple tips with that. One, you can add per key restrictions and authorized keys or in entries. So for instance, if you're using stuff for automated tasks, so an automated check-in, you set a cron job to go reach out and do something, then I would highly suggest these options. No port forwarding, right? Unless you're setting up something that's building a tunnel, you don't need port forwarding. If you're doing something setting up a tunnel, hey, awesome, leave that part out. No X11 forwarding. If you're doing something in cron, you probably don't need X11 coming back. No agent forwarding, so you're not sending your SSH agent across. And then no PTY, because you're probably not needing a terminal for that. If you can also force per key specific command, it's known as a force command. And it runs that command rather than whatever you send it, right? So I can send SSH remote key. If I don't send a command by default, it runs the default shell for that account on the remote machine. So if my remote machine, I've got bash, but on my local machine, I've got bash, but on my remote machine, I've got ZSH, then I will get a ZSH shell when I connect in if I don't give it a command. It'll say, okay, I'm going to create your login shell. Here you go, ZSH you have. But I can also give it a different command, such as hostname, to check out what that remote host is, and it'll run that command and exit. Same thing it does with the shell. The thing is, the shell gives you an interactive session, and then your connection ends when you exit the shell. So normally you want things around. So if I use force command, then it doesn't matter what I give it. If I don't give it a command, it's going to run whatever I've got configured for force command. If I do give it a command, hey, go do these things and gather all the data so I can exfiltrate it for you command, right? It's not going to run that. It's going to run whatever you've got configured for the host for that key in the authorized keys on that remote machine. Now, here's a tip for that. So host name is the example, so you can make sure you're connecting to the right box. But let's say you were doing something like rsync, which I'll give you an example in a second. And rsync, you run it locally, and then remotely it does a whole bunch of other stuff, right? It builds up a whole remote command and runs that. Well, I can now run rsync locally that will run the remote rsync command for me. And then using this echo of SSH original command, I can see what it was going to run remotely, and I can now make that the force command. So that if somebody gets a hold of my machine that I'm trying to back up over rsync, they can't run anything. Or if I'm trying to use that machine to back up rsync back from that remote machine, again, the only thing they're going to do is get the data. Now, granted, they're getting the data that's available, but they can't do something else. I'm locking them in. And of course, and then you can also do per key network access restrictions. So I can set up a key to only allow local host connections. And you think, well, why do you need to do that? You're already on localhost. Well, we can go back to slide 4, right? Whatever slide that was, where I showed you how to set up a tunnel. Now I can have that tunnel back to port 22. Back then you're thinking, well, why would you want to have a tunnel to the port you're already connected to? Well, now I can set up a key that's only available for over that tunnel. So now that key can have access to stuff that a normal external connection would not have access to. So command line tips. I mentioned I was going to get to the -N. That means no remote command. So now instead of running the shell by default, it just doesn't run anything. If I give it a remote command to run, it won't. If I tell it to run host name, it's going to ignore that and it's not going to run it. And then the -F is background off after authentication. Basically, we can say, think of that as background before you run whatever. So the example I'm giving here, I'm coming back to setting up a local tunnel, but the -n says don't run a command, and F says ask for authentication. So if I need authentication for this tunnel, I'm not using a key by default here. I can give the password to set up the connection, and then the shell, the SSH, the shell where I issued the SSH will actually come back to me because it doesn't leave that remote shell open. It just leaves up the tunnel. So now I have just the tunnel, but I didn't need to leave a shell hanging around. Another example or that's helpful on the command line is you can give up to 3 lowercase v's for verbosity. And this is really when your SSH connection isn't working. One, blame DNS. It's DNS's fault. But two, use the -v to find out why DNS is broken that's causing the problem. Now, there's a lot of reasons why it can be broken. Again, like I mentioned earlier, you can have bad permissions on a key and so forth. The lowercase v will help you get that. Warning, VVV is quite verbose. So start with a V, see if that works out, and add more verbosity as you need to. -G. This when you start getting really complex SSH connections or setups like I have occasionally, -G is something I discovered sometime last year. It's awesome. It shows you this is the thing I would run after I've parsed all these configuration files for you. So you can see what was built out of the monstrosity that I have in my configuration. Well, you can't see because I won't show you. But if you were me, you can see what you get out of the monstrosity of my configuration files. If you don't have a very complex setup, it's not useful. But for those of us that are doing a bunch of things for automation and everything, that is really cool. The -T, lowercase t, is to set up a pseudo terminal. The main place where I see this useful is if you're wanting to automatically connect back into Screen or tmux. So this might be useful for the presentation next month, right? If I don't know for certain actually for tmux, I think so. Actually, I think tmux doesn't need the terminal. It's a question to ask, right? So okay, so for Screen though, you definitely need it, and so you can use a -T. Should be in the example as well. To say set up a pseudo terminal so that Screen thinks it's talking to a terminal. And then SSH has a lot of different configuration options that you can use and they can also be used from the command line, even if there isn't a command line argument for them. And you can use the -lowercase o to call them. Basically, give it the full name of the option that you want to use, and then give it the value. Be conscious that you might need to have commas in between values. Probably you want to have quotes on them and stuff like that to protect stuff from the shell. This one was really useful for a while as newer releases of distributions were moving to SHA-1 for their fingerprint verification, and old machines were still using MD5. So you could force the new machines to give your old machine the MD5 fingerprint. Because the old machine or the older version of distro didn't yet understand how to use SHA-1 fingerprints. If you're still running into that, by the way, back to my earlier suggestions about please update. All right. SSH variables. PS1, I'm going to give some examples with this in a second, is your prompt. So when you connect up to a machine and it says your username at the name of the machine and other stuff, that's PS1. If you didn't know, you can change the value of that to get different things on your prompt. When you're connecting to remote machines, make sure you have enough information to know who you're talking to. I worked at a company that had a different host name for every machine. They had web 1 through web whatever in every data center. So you needed to know what data center you were in. If you just looked at short name, which web 1 am I talking to today, right? And same thing for lots of other services. And then SSH auth sock. That is something that you can use to reuse a connection that you've got. If you're using sockets. No, I'm saying the wrong word. Oh, we'll get there. Sorry. -A. But all right. Tools. SSH copy ID I mentioned earlier. SSHFS basically creates a remote file system. So you're you're making an SSH connection to a remote machine, and then it is turning that into a file system on your local host. So you can talk to it. It is highly inefficient. But if you want to make sure you've got a secure connection and make it a little bit easier just to use your command line tools without having to worry about spaces and quotes and stuff like that, that is very convenient. rsync can use SSH. That's the mechanism that's generally recommended. SCP is a great tool, but it's got a couple of security issues. So it's recommended not to use it, at least in those circumstances. But rsync is a great tool, does all the things that SCP does, or all but one or something like that. So use rsync if you can. Or use SFTP. I don't personally like SFTP. It's like an old school FTP client over SSH. Auto SSH is a way to automatically build SSH connections, including tunnels and so forth. So you can use that. That way, if a connection drops, you can use auto SSH to rebuild it, or the system will rebuild it automatically. I haven't taken time to figure out how it works on my own, but in the resources on I think the very, very last slide of this presentation, there are a couple of links to how to use systemd to automatically set up SSH connections if you want to go that direction. Do not use SSH key scan to go get all of your remote fingerprints. At least do not use those. It doesn't verify. It just does a port touch on the SSH connections, grabs the fingerprint, and then saves that to the file for you. But it doesn't do any kind of verification. So it is so open to man in the middle. Please do not use. It's a great tool for audits, but a horrible tool for making sure you've got a secure connection to begin with. All right, some extra stuff. Once you've set up your SSH connection, you're setting up a pipe from your local machine or from one machine to another machine. And you can throw whatever kind of data across that pipe you want to. By default, we have a shell connection. But you can do something else, such as tar. So I could actually go through and SSH to a remote machine, tell it to tar up a bunch of data, pipe that back to tar on my local box and say, untar the data, right? So I can go, so I'm sending a tar archive that I've built on the fly back and forth. This is something we used to do a lot. We don't need to nowadays because we got rsync and other tools. But really, anything you can do, you can cat image files and pipe them into an image viewer on your local box. Not really a brilliant thing to do security-wise, but you could do it. But if you ever find yourself needing to move some data and you're having utility issues with it, you could just use a raw SSH connection. This example, actually, I was going to say we don't hardly ever need to use. I took yesterday off, but we could have used this yesterday because we had a machine with out of control processes using up all the memory on the box. So this might have helped. But back in the day when you could run out of TTYs and other things like that, it doesn't happen so much anymore. I could SSH in, run a PS to grab the process table, throw it across the pipe, throw it into T on my local box so I can look at it as it's coming across, but I'm also saving it to a file so I can go back and start grepping on it and stuff like that. So I can figure out what it is that's causing the problem, figure out the process ID for it, and my next command is I SSH into the remote box and kill the process that's causing the problem, right? So I don't need to have a shell in that remote box in order to get in. It's slow, but it's also better than having to go through and reboot, especially if that's a remote box and stuff. And back in the day, rebooting remote boxes was far more painful than it is nowadays. And anybody that deals with data centers doesn't necessarily think it's a pleasant experience nowadays. But we're all cloud, so we don't have to worry. All right. rsync, these are the things I recommended. -E says to use SSH. I believe that's the default nowadays. And you can use SSH for your rsync connection. Now this is a world premiere. This is actually something that I've used for a few years, and I put into a opensource.com series that I never finished writing, so they haven't published it because it's not done. But this is a way to set remote variables and remote shell environments when you make an SSH connection. So SSH by default kills off a whole bunch of variables for security reasons. A good thing that it does. But what I can do with this particular script is I can go through and set variables. So here, this is coming out of my MySQL for Sysadmins presentation. I can set a MySQL PS1 so I can see which MySQL I'm on, because MySQL by default just says MySQL. Well, that's awesome. When I'm talking to dozens in a day, which I did when I was in MySQL DBA, which one was I talking to, right? So I wanted to set that up to tell me who I am and where I am. And I actually had a bunch of other information in there, but I kept the example short. And then I also want to set the PS1 in order to do this. And I need to do some RC file magic in order to make this happen. And we get a whole lot of backslashes in there. You feel like you're in a one-handed sword fight with just backslash, 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 backslash. But, that's the way it is. But in order to get the shell coding right. And again, I'm setting the host name. What I'm doing here is I'm using the host name variable if I have a fully qualified domain name on that remote machine. And I'm saying pop off the company.tld and leave just the short name or short name.dc or whatever you've got beyond those. So I can have a shorter prompt, but still see what data center I'm in. And that was important because, again, we had Web 1 through Web 500 in dozens of data centers around the planet. And I needed to know which Web 1 I was talking to. And especially, I'd like to know if I was talking to dev or prod, because shutting down the wrong one usually caused issues with somebody. And then I also go through and set my editing mode to VI. That's where I learned how to use VI. It was on the command line. So I also like that convenience piece in here. And then down at the bottom line is where I use this -T to give me a terminal or sudo tty, and then all the other stuff. And this last piece here, the +-C, is to change my grade. No, it's to go through and set it up to where anything else I had for that SSH connection as command line arguments get passed on as command line arguments. So if I was actually saying SSH to remote host to run the host name command, it would still run host name and exit and come back. So if I was telling it to do other stuff, it would still do that. All right. Please play the home game. Go out and do that. A friend of mine made this for me several years ago. Go forth securely, and thank you for listening to this. Hopefully some of you are still awake. It's a nice thing about remote connections. In person, we don't know either. Some places to find me. I mostly use for public stuff Mastodon. I'm Flock's advocate on floss.social. You can also find me in IRC. Ooh, I didn't update that slide. Oh, I feel so bad now. I am on Libera chat instead of that other place. And I also blog a little bit on the ActivityPub platform Plume. So Mastodon and Plume are both ActivityPub. And I'm behind, but this slide will later today be up on this final URL, lufthansa.com/talks. So you can get all the slides for it if you want to. And of course, the YouTube goes live at some point. I don't know if they need to do some things. So you can go back and watch it. You can watch me go faster or slower, however you like to watch YouTube stuff. Throw things at the screen. And then also upcoming presentations. I will be talking about ActivityPub and the Fediverse at Geek Beacon Fest in October, I believe is when that is. And that meant to come up here. All right, some credits for the different images that I used and the resources I was talking about. Speaking of Geek Beacon, Nixie Pixel, she's got a nice video up on YouTube that she did a few years ago that I discovered as I was setting up to present at PenguinCon. And I like especially, it's a good video overall, but I like especially her review of Foxy Proxy and her explanation of how that works. I think it's better than anything I've ever done. So I've been pointing people at her for that particular part. And I think that's it other than I continued on. Okay. Does anybody have any questions or things that I've missed in the comments? Because there's a behind my camera. I can hear somebody, but just barely.
So I have a question.
Yeah.
So you went through maybe a little too quickly for me the advantages or the reasons you'd want to do a reverse tunnel where you get onto a box and you get back. Could you just go over that again?
So the main reason I use that for is if I'm needing to use that third-party connection, where I have two endpoints that can't talk to each other, and they need a career counselor, right, in order to talk to each other, whatever you want to do, however you want to view that. So they can both set up reverse tunnels. So now either one of them can SSH directly into the other. That's the main place I use it for.
Thank you.
Yeah, there's occasions when, I work remotely, so I know that my company used to have an office. They actually closed it during the pandemic, but we used to have an office. I've been there once, and then they moved it. I've never been to the new one, right? And then they closed it. If I was still going to the office, I could be using that to make sure that my desktop inside the office has a method to get back to my local machine back at home, and vice versa if I need to be able to go through and do things. Consider your local security requirements of the company and so forth. But I also then use it so I can set up, for instance, and do backups and things for my parents, where they set up I have an auto SSH connection that sets up a reverse tunnel from my firewall back to their machine. So their machine isn't exposed to the internet, but I can still get in there and go through and do backups and do updates and do things like that for them. All right. Any other questions? All right. Sign up and get for your book, whatever.
Yeah. Thank you very much, Hans. I really appreciate that.
You're welcome.
So we have a giveaway, and this giveaway, we will be selecting one winner at random from the people that are in the live stream. So if you don't want to win, then hop off right now. But if you do want to win, and you would like to win one of the books that are part of the Total Mastery Bundle. So Michael Lucas is trying something out with a Total Mastery Bundle, and he's put up 15 different books. We can give away one of them, and we will give away one of these books. So you can choose from such things as DNSSEC Mastery, Ed Mastery, FreeBSD Mastery. There's several of them in that series. SSH Mastery. I wonder if there would be a use for SSH. Tarsnap Mastery, TLS Mastery. How do you get a recording of this session? That will be available up on our website, on the and also on our YouTube channel. Once I manage to figure out how to get all of this stuff situated, so hang tight.
Okay,
it'll be on YouTube.
Can I say two real things real quick? I forgot.
Go ahead.
So first of all, I should have put this in the credits. Thank you for participating in the presentation and providing the tunnel. That was awesome, Craig. And thanks to Murph for helping me think of different things and brainstorm about some ideas I could use for props during the presentation. And then also, I know you all have feedback form, you do stuff. If anybody wants to give me feedback specifically on how well or poorly this Price is Right stuff worked, please feel free to get that. If you do get that, please pass it on. It's the first time I've tried that in a am I on the screen method.
Right.
Thank you.
Excellent. No worries. So again,